All right, 1.4, the method of elimination. So what we're looking at here is the process of elimination for systems of equations. In linear systems, there's a certain level of steps that you need to follow. So here are the steps. First of all, line 1, you're to arrange the two equations so that the like terms are aligned. So the first step is to align the equation. Align is your first step. 2 is you're to make the coefficient of one variable the same by multiplying one or both equations by a number that makes it the same. So the second step is to multiply. First step is to align. Second step is to multiply. Third step, to eliminate one variable, add or subtract the equations by combining like terms. So what you're doing here in the next step is to eliminate. So again, step number 1 is to align. Step number 2 is to multiply. Step number 3 is to eliminate. Once you've eliminated, you can then solve for the remaining variable. So that is still part of the elimination step. The next step is to substitute. You substitute in the value of the variable that you just solved to one of the original equations that you were given to solve for the remaining variable. So if we were to just eliminate 6 for now, we have the first step is to align, second step is to multiply, third and fourth together is to eliminate, finally substitute, and then the last step is to check. So here we go. The process of elimination is to follow the following acronym. Align, multiply, eliminate, sub, check. Just like we had one for substitution, we also have one for elimination. So some of you remembered it as A, me, S, sub, check. A, me, sub, check. A for align, M for multiply, E for eliminate, sub, and then check. And something to note too, guys, you don't always need to check, but if you always remember to do it, it's a good way to check your answer, to make sure that you've got the right answer to complete the final statement. All right, let's look at example number 1. Solve the system and check. So here's our system, all right? And what you should notice right away is that they are definitely not aligned. And you should automatically, first step, is align the equations so that the x's line up, the y's line up, and so do the equal signs. So we've now aligned the first equation to be like this. We moved the minus 13 over to here, it became 13. And 5x minus 4y equals negative 7. So, what do we call these? Well, this is line 3, folks, and this is line 4. Once we have 3 and 4, we can now say, okay, I've aligned the equations. The next step is to multiply. What am I going to multiply so that I can eliminate? The easiest way is to look at the first numbers. What we're going to do is multiply this line, line 3, by the first number in line 4. That's right, folks. One more time. Take the numbers in line 3, the equation in line 3, and multiply it by the first number in line 4, which is 5. Then we take line 4 and we multiply it by the first number in line 3. Because we've aligned everything, we can then just multiply the top line by this number 5 and the bottom line by this number 4. All right, so again, let's write the step out here. 5 times line 3 and 4 times line 4, and we're going to find or write out the new equations because we multiply each of these by 5, so we get 20x plus 15y is equal to 65. Next, we're looking at is 20x minus 16y is equal to negative 28. What are we doing now? Well, we have equations 5 and 6. And what we're going to do is we've now done align, multiply. The next part is to eliminate. What are we going to eliminate? 5 minus 6. When we eliminate 5 minus 6, this one will disappear. By collecting like terms, we will make 20x minus 20x disappear. So 5 minus 6, and we put a subtraction sign for each lined up. So 20x minus 20x is going to give me 0x. 15 minus negative 16, 15 minus minus, turns into 15 plus 16, which gives us 31y. And 65 minus negative 28 is going to equal 93. So 31y is equal to 93. We divide both sides by 31 and we get y is equal to 3. What do we do next? Well, let's go through the steps again. We aligned, multiply, eliminate, and now we're going to sub this to find the next value, the variable. So we need to find x. Now, why did I choose to sub in 1? Well, folks, honestly, just because. I put it into 1 and then later I'll check in 2. We could have substituted in 2 and checked in 1. Either way, I guarantee you'll get the right answer, or the same answer that I will have. 4x plus 3 times 3 minus 13 equals 0. And then we simplify. You get 4x is equal to 4 and x is equal to 1. How did I go from this line to this line, folks? Well, let's see. 3 times 3 is 9 minus 13. 9 minus 13 is negative 4. And we bring it over to the other side, it becomes positive 4. So 4x is equal to 4. That means x is equal to 1. So now we have our x and we have our y. So we're going to check our answer in equation number 2. Just like in the Latin substitution, we do the same thing here. So we're going to check, plug it in. Lo and behold, we end up with values of negative 7 is equal to negative 7. Left side equals right side. We've checked that it's equal, and that makes us happy, folks. So therefore, the solution is 1, 3. And yes, please give me a therefore statement to complete your final thoughts. All right, let's move on to the next one. Example number 2. You're asked to find the point of intersection of the linear system 5x plus 2y equals 15 and 4x minus y is equal to negative 1 using elimination. So you're forced to use elimination here. So we do this by aligning, and that's what we're doing the first one. We align it, calling it equations 1 and 2. Notice that they're already properly formed, so we line it up, draw a line, and call it 1 and 2. They're already aligned. Then you take, now note, I want you to look here, we're going to practice by trying to eliminate y here. Why do we want to eliminate y? Well, we would only have to multiply this whole equation by a number, hint, same number up here, multiply just this one by 2, and we'll be able to eliminate. So let's look at that. And then we'll go back and do it the way we did in the first unit, just so that you get into some practice. All right, so 1 times 1, that means the equation number 1 will stay the way it is. Equation number 2, we're multiplying by 2. So equation number 1, write it as it is. Equation number 2 is going to be 8x minus 2y is equal to negative 2. Remember, you multiplied this whole equation by positive 2, and that's what I did. So we have lines 3 and 4. So we've done the align, we've done the multiply, now we need to eliminate. How are we going to eliminate? Well, looking here, we're going to eliminate by getting 0 here, because these are essentially almost the same. How are we going to get 0 for y? Well, 3 has to add to 4, because if I take positive 2 and I add negative 2, that will give me 0. So the goal is to get 0. So if the signs are different, just like they are here, they're different, we're going to add each of them. If they're the same, like the previous example, you would subtract. So, adding the two equations, you get 13x is equal to positive 13, because this is 15 minus 2, which is 13. All right, 13x is equal to 13. X is equal to 1, folks. And now, what we've done the elimination step, we need to sub. Sub it in equation number 2, and you get y is equal to 5. Why did I choose 2? Again, folks, just to be different so you can see you're not forced to do it only one way. All right, we checked the value, and lo and behold, in equation number 1, we get this final value. Left side equals right side, and that makes us happy. All right, so this is the way we solved for equation number 2, example number 2, using a different way by eliminating y. We're going to stop the video now and move to the next video so that I can show you how to eliminate using elimination by eliminating x for the exact same question here like we did in example number 1. All right, folks, see you on the other side.